It's JD here. Today we're going to take a closer look at one of the interesting chapters in O-level mathematics. This chapter is for functions. I'm going to explain what a student has to know when it comes to functions, but I'm going to do so by means of an example. Here, given that f of x is equivalent to 3x plus 5. So we have a certain function here. The function is taking certain values, processes them in such a way that when they come out, the input value will be multiplied by 3 and added a 5. We also have another function which is g of x, and g of x is equivalent to 1 minus 4x. Then they said find a f of minus 2, b the inverse of f of x, c the inverse of g of 2, d f of g of 2. We call these composite functions. And here we've got the g of f of x. Again, it is a composite function. So by the end of this example, you must be able to find the f of a certain value if that function is given. You must also be able to calculate the inverse of a given function. You must also be able to work with composite functions. Okay, so let's start. So the first one here, they said f of x is equivalent to 3x plus 5. So if f of x is given, we can also find f of anything by simply substituting that thing wherever there's x. Like in this case, on part A, they say find f of minus 2. So can you see where there is x, we have replaced with minus 2. So by the end of the day, it will be 3 times minus 2 plus 5. And if we simplify this, we get minus 6 plus 5. And if you are still familiar with integers, minus 6 plus 5 straight away gives us minus 1. So yes, f of minus 2 is minus 1. Right? You may see other questions like find f of k. What will be f of k? F of k by the end of the day will also be 3k plus 5. And you can't simplify this further because it's algebra. Right? So you just need to be familiar with that. But don't worry, as it was not part of the example. Let's quickly move on to part B. On part B, we want to find the inverse of f of x. So given f of x, how do we calculate the inverse of a given function? So the function here, f of x is equivalent to 3x plus 5. Right? So there are certain stages that you need to put on your fingertips, as those stages will help you if you're trying to calculate the inverse of a given function. So step number 1, write f of x as y. So it will be y is equivalent to 3x plus 5. That's the very first step that you have to do. Then step number 2, you need to swap the variables. Wherever there's y, you replace with x, and wherever there's x, replace with y. So exchange the variables. So how are you going to do that? So this is going to be x is equivalent to 3y plus 5. So we've exchanged the variables at that point. Then step number 3, you now need to make y the subject of the formula. So in other words, you need to solve for y. You need to move all the other terms to the other side until you get your result as y is equal to something. So how are we going to do that? You need to do that step by step. So let's take plus 5 to the other side. So we get x minus 5 is equivalent to 3y. Remember, our target is to make y the subject of the formula. So to do that, we need to divide both sides by 3. So if I divide here by 3 and also divide here by 3, so obviously this 3 and this 3 cancels, and y will then be equal to x minus 5 all over 3. So yes, we have successfully managed to make y the subject of the formula. So the next thing that we have to do, this result we have is the inverse. So we can replace y with the inverse of f of x. So the inverse of f of x is x minus 5 all over 3. So that's our solution. So this is our solution. That's how we calculate the inverse of a given function. Let me reiterate this. This is very important. If you want to find the inverse of a function, step number 1, write f of x as y is equal to. Then step number 2, interchange the variables. Wherever there's y, write x. Wherever there's x, write y. Then step number 3, make y the subject of the formula like I then did here to arrive at this particular solution. So yes, that's how we calculate the inverse of a given function. Let's quickly move on to part C. On part C, we have, let me just quickly read part C. It's the inverse of g of 2. So we want to undo what g of x has done and get the function of the inverse. Once we have the function of that inverse, we then need to substitute 2 into the function of the inverse. Quite crazy. But who is g of x? Let's write down g of x first. So g of x is equivalent to 1 minus 4x. What about the function of the inverse? Because here we need to substitute 2 into the function of the inverse. Like I explained here on part B, how best do we find the inverse of a function? Replace g of x with y, so it's going to be y is equivalent to 1 minus 4x. Then the next step after replacing g of x with y, we then have to interchange the variables. So let y be x and x to be y. So we arrive at this point. And then from there, let's make y the subject of the formula. So we can take minus 4y to this side, becomes positive 4y. We can take x to this side, 1 minus x. The next move, let's divide both sides by 4. So if you do that, y is equivalent to 1 minus x all over 4. Therefore, that's the function of the inverse of g of x, which is 1 minus x all over 4. So once we have the function of the inverse of g of x, the next thing that we have to do now is to find the inverse of g of 2. So we have to put 2 wherever there is x in the function of the inverse of g of x. So here the inverse of g of 2 will be equivalent to 1 minus 2 all over 4. 1 minus 2 gives us minus 1 all over 4. So yes, this is going to be our solution. Quite interesting. Let's take a closer look at part D. Part D. Part D is written f of g of 2. This is quite crazy. We call these composite functions. What is a composite function? A composite function is a function of a function. So it's like we are taking the result of another function, and that result of another function then acts as the input value into another function. Like in this case, we need to know who exactly is g of 2. So once we have g of 2, we can take the result of g of 2 and feed into the function of f of x. Okay, so here we know that g of x is equivalent to 1 minus 4x. So g of 2 will then be equivalent to 1 minus 4 times 2, which is equivalent to 1 minus 8, and we get minus 7. Look at this language. So obviously we are saying g of 2 is, what is g of 2? G of 2 is minus 7. Therefore, it means the problem which is given of f of g of 2, mathematician can then write it as f of what? Who is g of 2? Here in our calculation, g of x was given. So g of 2 can also be calculated. So f of g of 2 is the same as what? Is the same as f of minus 7. Because we know that g of 2 is minus 7. So we can write this as f of minus 7. And how do we calculate f of minus 7? That's again quite interesting. What is f of minus 7? Remember, we know very well that f of x is equivalent to 3x plus 5. Right? What about f of minus 7? What about f of minus 7? Obviously, to be 3 times minus 7 plus 5. 3 times minus 7, we get minus 21 plus 5. And 5 minus 21, we get minus 17. So yes, not minus 17, sorry, minus 16. So yes, that will be the solution. But I want you to watch very carefully. Composite functions are very interesting. You need to be very careful. We are saying find f of g of 2. And the first thing that we have to ask ourselves is, who is g of 2? Right? But g of x was given. So to calculate g of 2, wherever there's x in g of x, we substitute 2. And in this case, we manage to see that, okay, g of 2 is minus 7. So if we go back to the problem where they say f of g of 2, since g of 2 is minus 7, we can now rewrite that f of g of 2 as f of minus 7. As minus 7 replaces who? G of 2. And then if we simplify this, then we get our solution. Quite interesting. Let's take a closer look at the last problem. The last problem. So the last problem, it's written g of f of x. So this is equal to, so if I keep this as a g, who is f of x? Here I'm saying f of x is 3x minus 5. So wherever there's f of x, I can replace with 3x minus 5 because I'm saying the two are the same, they are equal. So who is f of x? Is 3x plus 5. So if you read this problem now, you read this problem as g of what? Of 3x minus 5. How best are we going to simplify that? We know very well that g of x is given that it's 1 minus 4x. Right? What about g of 3x plus 5? So wherever there's x in g of x, I'm going to replace with 3x plus 5. So by the end of the day, it will be 1 minus 4 times 3x plus 5. And if I simplify this further, it will be 1 minus 12x minus 20. And 1 minus 20, I'll get minus 19 minus 12x. So this will be our final solution. So yes, that's all I can say so far as composite functions are concerned. But whenever you see functions, you need to know, given a function, you must be able to calculate f of a certain value, maybe f of 2, f of 3, f of 7, f of minus 1. Also, given a function, you must be able to find the inverse of that given function. You must also be able to handle what we call composite functions, which is a function of another function. So let me just quickly give you an exercise, but I'm just going to twist a little bit on these problems so that you can also try as an exercise. So I'm going to change my functions here and keep the whole exercise as it is. So here I'm going to have a function called 3 minus 7x. Here my g of x is going to be 12x plus 5. So yes, I want you now to try this as an exercise. Do this as an exercise. Given that f of x is 3 minus 7x and g of x is equivalent to 12 plus 5, find all these problems. Let me know if you get the solutions right. Awesome.